All right, so good morning, everyone. We'll be discussing the Leetcode weekly contest for today. The date when I'm recording this video is 25th of February, and let's take the contest. Yeah, so the contest number, if we see, that is 386. Yeah, so weekly contest 386, this is what we'll be discussing today. A brief overview. This contest was difficult as compared to the last 3-4 contests that we have observed in the past. So let's get started. Let's start with the discussions. Okay. Yeah. So we have the first problem now. Let's firstly move on to the whiteboard. Let's do the usual like we always do. Weekly. What's the number? It's 386, and we are discussing problem one. All right. You're given an integer array nums of length and you're given an integer array nums of even length. We have to split the array into two parts, nums1 and nums2, such that both of them have nums dot length divided by 2. That is half of the original array's length. Both the arrays should contain distinct elements only. Okay. So we need to return whether we can divide the original array into two sub-arrays, or not sub-arrays, two different arrays wherein all the elements are distinct. That is, there is no repeating element. So quickly, the observation for this question is, let's say if I have 10 elements, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So both of them will have 5 elements, okay. Now let's say if one of them has a repeating element, okay. Let's say it has 1, 2, 3, and 5 and 5. So 5 is repeating, and here let's say the 5 is not repeating or it's not present, anything like that. Okay. So if you observe carefully, what is the observation that if any element is having a count greater than 2, then you cannot divide it. Okay. Because let's say if any element is having a count 1, so of course it will go to one of the two arrays. If it is having a count of 2, so one instance of that that one instance of that element will go to both the sub-arrays, 1 and 1. Okay. But if it is any number greater than 3, then let's say you give one instance here, one here, and the third instance will have to go to one of them, so that would be repeating. So that is the observation that any element should not have a count greater than 2. Okay. So if the count for any element is greater than 2, then you cannot divide the given array. So yeah, that's the observation. And again, let's see the code for it. It's a pretty simple code. I created a map here. You can create an array as well because the constraints are pretty small. So map, count the frequencies, check if the frequency for any element is greater than 2. If it is, then return false, else return true. Okay, simple. 4 lines of code, pretty simple. I hope everyone would have done this question. Not more than a minute is needed to code this question. Okay. So again, the complexity for my code would have been n log n because I'm using a map, but you can go for O of n as well if you create an array. So time complexity is O of n, space complexity is O of 100. Oh, because you're having n elements, okay? Sorry, elements till 100. So if you create an array, the size of that array will be 1 over. So that is n and O of 1, 0. So this is again constant only, kind of. So O of n and O of 1. Okay. So this solves the first problem. Let's move on to the next question. The first two problems were still doable, I would say. It was from the third problem wherein the contest was going bonkers. So, alright, so let's go to the second question. There exists n rectangles in the 2D plane. You're given two zero-indexed 2D integer arrays bottom left and top right, both of size n into 2, where bottom left of I and top right of I represent the bottom left and top right coordinates of the ith rectangle. Okay. So ith element of both the 2D arrays would represent their bottom left and top right coordinates. Okay. We need to select a region formed by the intersection of the two given rectangles, and we need to find the largest area of the square that can fit inside this region if you select the region optimally. Okay. So we need to tell the largest square that can fit inside and that can fit inside the intersection of any two rectangles. Okay, and we need to return the largest search area. And if there is no intersecting region, see if there is any intersecting region, then of course there will be an answer for the square. Yeah, there would be some possible area. Okay, but let's say if it is not there. Okay. Let's say if there is no intersection region, then only you cannot find any area. So of course you'll be returning zero in that case. Okay. So again, firstly see the constraints. They are pretty small, 10 power 3. Okay. The values are 10 power 7, but that doesn't really matter. So the 10 power 3 means that you can go for an n square solution. Okay. Let's see how we can code it now. Because when it comes to n squared, the solution simplifies. Okay, you can go for the brute force as well in this case, and that is what the solution is. That you iterate over the, let's say, left array. Okay, and you iterate over the right array. Wait a minute. Wait a minute. Sorry, not this one. This one. I got confused. Sorry. All right. Yeah. So you'll write your first loop, okay, I starting from 0 till n, another loop j starting from I plus 1 till n. Okay, this is j, this is I. Okay. And let's say you take the ith index and the jth index, you take their left and the rightmost, and same for this one. Okay. So it would be something like this is the ith one, say ith rectangle, and assuming that there is an intersection, this is the jth one. Okay, so you have these four coordinates. I'll take a different color now. This one, this one, this one, this one. Okay, so you can take the minimum and maximum of these coordinates, and you can get these two this thing, this region. Okay, you can get the lengths for this region if you think about it closely. Okay, think about this a minute, that how will you select the coordinates? Okay. Uh, for no intersection, the case would be that the rightmost of the ith one, okay, the right corner should be less than the left or the left bottom of the jth one. So it would be something like this for no intersection case. Okay. This and this. You need to compare these two for getting no intersections. Okay. I hope it's pretty clear. We'll see the code once. Okay. So once you have these, again, let's come back to the intersection. We got diverted. Okay. So this intersection, first you need to check. If there is no intersection, then you move on to the next case. Else, if there is an intersection, if you find that this condition does not hold true, that means there is an intersection. So you will take, for the left corner, you will take the minimum of these two x coordinates. Okay. Let's say this is x1 and this is x2. Okay. So you need to take the minimum of both these two, that is x1. Similarly for y, for the left corner, you need to take the minimum value of both of them. Let's say this is y1 and this is y2. Okay. So, yeah, wait a minute. Yeah, so for the left one, again, you will take y1. Alright. So similarly, you can find the coordinates for this one as well. Okay. Think about it a bit. Alright. You'll get it. So once we have these two coordinates, let's say x2 comma y2, we can easily find the lengths. All right, now the lengths can be easily found because x1 remains same, so the y length would be y2 minus y1, and the x length would be x2 minus x1. Okay, so this is the possible rectangle, length and breadth, and you multiply them and you get the uh, area. All right, and you can update it in a global answer variable. global answer variable. Okay. So the complexity for this solution would be n square. Space complexity O of 1 because we are not using any additional space. Let's see the code quickly. Okay. Iterate over the, again, this is n only. Okay. So iterate over the array from I till nums1 dot size, and similarly for j from I plus 1 till nums1 dot size. Okay. You select the minimum x, you select the maximum x, you select the minimum y and the maximum y. As I said, this is what you'll have to do. Okay. For the intersections, you need to take the minimum and maximum values of x and y and you compare. If minimum of x is less than maximum of x and minimum of y is less than maximum of y, if it is true, that means there is an intersection, else not. And now if there is an intersection, so of course from this only you can get your side as well. Okay, because you need to take a square. Okay, keep that in mind. These are the two possible sides: max x minus min x and max y minus min y. So these are the two possible sides. So if there is a square, let's say if there are two sides, 2 and 4, I tell you what is the greatest square possible. If I ask you, so what would you say? Sir, we'll take 2 into 2, that is 4. I cannot take 4 into 4 because that's not possible, because the other side is at max 2. So again, I'll take the minimum of these two as the side of the square and I'll update my answer and I'll return the area. Okay. If you submit this, then this will of course get accepted. I had submitted it, so yeah, I was getting the correct answer. Alright. Let's quickly move on to the third question now. Okay. Now this is where the contest starts getting difficult. The first two questions could have been, I think, solved in not more than 15 minutes. This is where you needed a lot of time. And if you see the number of accepted solutions, that is only 915 even after 2 hours of the contest. Not 2 hours, 3 to 4 hours, okay? So, and same is the case with the fourth question. Not many people were able to solve it. Although for the fourth question, it might or as well depend on how well you have practiced and everything. But chalo, let's firstly discuss the third question. Okay, you're given two one-index integer arrays nums and change indices. Okay, so these are one index having lengths n and m respectively. Initially, all indices in nums are unmarked. Your task is to mark all indices. Okay, so we are marking them, all the indices. This is what our task is. Okay, and what operation do we have in each second s in the order from 1 to n inclusive. Okay, so that means we traverse the uh, second change indices array in the order from 1 to n because this is one index. Okay, and we are signifying that as seconds. Okay, every second we move one index. Okay, we can perform one of the following operation. We can choose an index I in the range 1 to n and decrement nums of I by 1. Okay, so first operation is either we select any index from nums and we decrement it by 1. Next is if nums of change indices s is equal to 0, we mark the index. Okay, so we can mark the index if the value of that particular nums element is 0. Okay, third operation is we do nothing. Again, that is not needed at all. Okay, so we need to return an integer denoting the earliest second in the range 1 to m, where all indices in nums can be marked by choosing operations optimally, or minus 1 if it is not possible. Okay, so we need to check if it is possible to mark all the indices within the range 1 to m, or if it is not possible, then you can return minus 1. Okay, so let's see the constraints for it. Nums length 200. Okay, that's it. Yeah. So 2000 is what the constraints is. Now, if you think about this, you can go for an n square solution or you can go for a binary search as well. Okay. So any of the solutions you can opt for. I opted for the binary search. So I'll discuss that because that's the most optimal. Okay. And all right. Also, think about this. For this question, observations were very important. Observations and algorithm. That is why it's a good problem, and that is why it has very less submissions. So the First observation is that, let's say if I have any element x in nums. So what is the number of operations I need for this element to mark this index? Let's say it is present at an index I. So how many operations do I need? I will need x plus 1 operations, x operations to decrement it to 0, and then 1 operation to mark the 0th element. So this makes it x plus 1 operations. Okay. Now if I generalize this for all the elements, so what will I get? Okay. That is sum of nums plus n. Okay, this is the minimum number of operations that is needed. Maximum number of operations I have, that is n. I cannot go beyond that. Okay, so this is my range. Okay, this is my range. Of course, you can, like when you code the solution in the contest. See, you know that any number less than this, it won't be possible. So you can even start from one that won't make a difference. In your binary search, the function you make to check whether a particular answer is possible or not, it will return false. So the range would become 1 till n. Okay, it's up to you because during the contest you do not have this much of time to get into all the nitty gritties. Of course, this would have been very, very optimal, but this will also get accepted. Okay, it won't make a lot of difference. Alright, so that is the first observation. Alright, now let's talk about the next observations. What do we have? Let's say if I have a particular integer x as my answer. Okay. Yeah, let's say between 1 to n, I choose an integer a. This is my possible answer. Okay, so I'll take a consecutive seconds from the start. Okay, now what will I do to check it? I'll take the first a elements from the change indices. Okay, change indices. All right, and I'll mark all the elements. Okay, what I'll do is I'll firstly check that the ith element of this this is change this change indices from 1 till a. I'll check if the range from 1 to a covers all my integers or not. Okay, all my elements of nums or not. Okay, that means all the values between 1 to n should at least be present once. Okay, if that is the case, let's say if any value in between, say y, is not present at all in this range, then I cannot take this as an answer. So I'll return false at that instant only. Okay, that is the first observation. Next observation is, let's say now I have marked. Okay, I mark all the elements 1 till n, marking as in that I know that at that which indices of this indices array corresponds for the element. Okay, corresponds for the index. Okay, so I'll mark all of them and I'll check my operations again. We'll have to move to the code for this now. Okay. Let's firstly discuss the approach. Listen to me carefully on this. Okay, now listen what I'm saying. So once we have marked all the indices, marking as in that we have selected every change indices and we have mapped it to some index I. Okay. So this goes something like change indices. Okay. And I have 1 till n. Okay. This is 1 till a. Okay. So I mark, let's say 1. First index corresponds to this index. Second would correspond to this. Third would correspond to this. Fourth would correspond to this. A would correspond to this. This is a case I'm taking. Okay. I have marked all of them. Now I need to check if all these operations are able to decrement my given value to 0 or not. Okay. All the values. If it is possible in the given A operations, then I return true, else I return false. Okay, this is what I will be doing. Now let's move on to the code to see it first, and then we'll return back here if just for a closing statement on this question. Okay. All right. So this is again the optimal one. All right. Minimum needed, blah blah blah. If it is greater than n for a case, then of course the answer is not possible, so we return false. We have the limits. Okay, we check if it is possible. If it is, we decrement the high pointer to mid, else we increment the low pointer to mid plus 1. Okay, yeah, that's it. So and else we return -1. Now let's see what we are doing in the function. We are taking number of moves, that is possible answer, nums and indices. Okay, all right. Last occurrence. Okay, this is where we are storing that what is the last occurrence of every element of nums. Okay, in the change indices. If it is possible that any index of this comes out to be -1, that means it is not possible to make that element 0 in this many number of operations, so we cannot go for it. Okay. I'll take the moves, I'll take the ith element. Okay. I'll check if the value is -1 for the last occurrence of indices. So I'll update it accordingly. Okay. I'll update it if it is -1. If it is not -1, then why would I update it? Because I just want the final value, right? This is what I'm doing at the moment because I'm just checking if it is if all the elements are at least getting one chance to give set to be 0 or not. Okay, this is what I'm checking. Again, I check if any of them is -1. I return false at that time only. Next, I take the pairs. Okay, so I store them as pairs, the last occurrence and the indices I. I sort them. Now this is important. Why I am sorting it? Think about this. I am only sorting it because what I'll try to do is I'll try to give operations to the elements which come first, okay, for which the indices has a lesser value. Let's say the value for indices is 1, 2, 3, 4, 5, 6, 7. Okay. There's a possibility, let's take 2, 3, some values randomly. Okay. So I'll firstly try to set this element, this index value to 0 because this is coming first, okay, not this one. Alright. So again, as I said, for this kind of a contest, for today's kind of contest, you'll have to give some thought process on your end as well. Okay. I'll sort the values now. Okay. And I'll extract the indices and the answers now. Okay. So the last index. Okay. Now I'm taking the ith element. So what is the last occurrence of this ith element of this array in the change indices? That is VPR of I dot first. That is this value. Okay. I'm taking the actual index, okay, that which value of nums array I'm trying to set to 0. So that is stored at the second position, that is I. And how many operations are needed? That is nums int -1 because this is one based indexing. So I'm taking int -1. Okay. Now how many operations do I have already? Okay. This is very important. So I stored a count variable that the number of operations I've done till now. Okay. So how many available operations I have? That is last indices -1 minus count. Okay, this is the number of operations. Try to think about this. Count is a number of operations I've already done. Okay, last indices, again, it's the last index that how many operations could have been done. Okay, yeah, that is it. So mhm. That's all. Those the available operations. If it is greater than the number of needed operations, so I can perform that many operations. So I'll do count plus equals to needed plus one. Else I'll return false because the available would be less than needed. So I do not have that many operations to set the element to 0. So I'll return false in that case. Okay. Again, as I said, try thinking about this. Give it some time. You'll get it. All right. And yeah, that's it. That's it. And we are doing -1 because we are taking zero based indexing kind of, okay, because this was given in one based indexing. So that is why I need to do a last index -1 minus count, which is the number of operations already done. Okay. So yeah, uh, yeah, that finishes the code for this question. Okay. I hope uh, you could have had some insight into this question. Okay. The complexity for this is n log n. Okay. And the space complexity is O of n, you can say, worst case scenario, because we are using vectors to store our operations. Okay, that is O of n, and that could have been done. Yeah, so that is O of n, worst case. Yeah, so this is the TC, and this is the space complexity. All right. Now let's move on to the fourth question. Okay. Fourth question is an extension of the third question. Okay. I'll tell you what is different in the fourth question. So the rest of the question remains same, but this time instead of the indices, they have given us uh, sorry, instead of change in constraints, they have given us a new operation altogether. Wait a minute. Yeah. So if you see, we have everything else remains same. Choose an index I in the range element, decremented by one. Set nums change indices to any non-negative value. Okay. So what they are telling us is that we can set, this is the new operation, that every second we can change the change indices S element to a non-negative value. That means you can set it to zero in a single operation. Okay. Choose an index I where nums of I is equals to 0 and mark the index. So this is the same operation as the previous one. And the last one is do nothing. So that means we set idle and we do not do anything. And we need to return the same thing, that the earliest second where all indices in the nums can be marked to 0. Can be marked or not. Okay. This is what we need to return. Alright. Okay, so the hint for this question is, again, if you see, this question has been solved by not more than 50 people. So this is something which, even if you avoided this question and you did the rest three questions in a very short period of time, you could have easily landed at any range between 150 to 400. Okay, ranks. I'm talking about the rank. So for the this kind of a rank in the top under 500 or anything, you did not need to solve this question. Okay. So again, I and because this is a difficult one, I'll be honest, because this is a difficult one, and it all depends on how much competitive programming you guys do. Okay. So this is that kind of a problem. I'll try to give you some insights into that. The approach would be very similar for this question as well, but because of the that operation, that new operation, a lot of things will change as well. Okay. Now let's see the insights. So what is the minimum time which is required? The minimum time, if you think about this, that is required is n. Okay. N seconds is required to mark all of them to zero. Okay. And the maximum time that is required is, again, this time it is sum of nums plus n. So the answer will be, this is the number of operations needed. Okay. This is the range of the answer. And you still have the range from that 1 till n. Okay. But you need to check that any value should not be kind of greater than this. Okay. It cannot be greater than this. Okay. Because of course this is the worst case solution. So this is the minimum answer that should come, kind of. Okay. All right. And let's discuss this question this way only, okay? Because there's not much to be explained on the board here. I'll try to help you out with the hints as well, okay? We need at least n seconds and at most sum of nums of I plus n seconds, okay? So this is the possible range as I discussed earlier. Again, you have to go for a binary search operation. All right. Now try to understand that if any value you are setting it to zero using the new operation. So what are the possible what cases would you want that it should not already be equal to zero? Of course, if any element is equal to zero, why would you do that operation again on it? Okay. So it has to be a non-zero value. All right. And it should be the first position where change indices occur in indices. Okay. Now this is important. This is okay. If you are taking, in the previous case, what we did was we are taking, let's say, A as our answer. Okay. So this is like the values of the indices array. Now let's say some index I occurs at this point. So this should not be its last occurrence. It should occur another time. One is to set its value to zero and the other one is to mark it. Okay. Alright, this is very important observation. So if this does not hold true, then you cannot do the operation on that element and you return false in that case. Okay. This is an observation for this. Okay. Time needed, we check if we can mark all the indices at some index as we need to make. Again, this is the same binary search thing. Okay. So Yeah, this is the binary search thing. Using a non-negative operation on some nums indices that satisfy to maximize. Yeah, again, these all are the same things. They are just telling you about the binary search operation. Okay, okay. Maximizing the sum of this thing can be done greedily using a min priority queue and going in the reverse, starting from second x to second x to 1. Okay, this is what we did in the previous question as well, that we went from the last second to the first second. Okay, if you remember, and ensuring that for every non-negative integer operation on nums chosen, there is a second index j in the range where change indices can be marked. As I said, that there has to be at least two values. Okay, so you need to maximize the sum of these values. Okay, you need to maximize the sum of these number of operations that you are doing. All right, so that you can use all of them. And yeah, again, now answer is the first value of x. This is again the same thing, so it's all the same. If you what they're stating is that you need to use a priority queue in this case, because you will be having two operations for every element. One is to set it to 0 and the other is to set it to this name, uh, market. So yeah, again, let's go through the code again. As I said, this is a difficult one. So I can only help you out with some insights for it, that how to develop a problem solving methodology for this. So you take the low value 1, the high value n, you take the middle value, you check if the answer is possible, uh, change the high pointer, else change the low pointer. If low is equals to m plus 1, that means there was no answer. So you return minus 1, else you return low. Okay. Now let's see what we are doing in our function. So we are passing three parameters, nums, indices, and mid. That is the possible answer. Okay, what I'm doing here is that I'm checking if the answer is m plus 1. So of course this is true. Okay, if let's say I strike the condition where answer is equals to m plus 1, although I do not have these many number of operations, but I'll return true because I know the answer is this value will return true, because if I take any value greater than n, then of course the answer would be possible. It doesn't really matter whether it's even possible or not, because we cannot take it either ways. Okay, so we are doing this case to handle the base condition of this one, that if low is n plus 1, so we return minus 1. Okay, now I'm creating a Boolean scene. Again, as the previous question, I'll firstly check if it is possible, if it is covering all the elements or not. Okay. So if it is not seen, I'll mark it as true and I'll push it to the pair vector. That is the operations that we are doing for every index j. Okay. So yeah, this is what I'm done. I take the size, the remaining operations. Okay. Okay. This is where I'm storing the remaining operations kind of thing. All right. Again, you now traverse in the reverse order. Okay. If any value is greater than 0, you push it to the queue and you push this thing, the number of operations that you have. What is C of j? Yeah, C of j is the number of in that number of index you have. You increment the remaining, decrement the k variable. Again, as I said, this question can't really be taught a lot. I can give you some insights on that. Okay. And at the end, what we are doing is that at every step, if you see, okay, we are pushing it to the queue, and while remaining operations are less than priority queue, okay, that how many elements are remaining to be set. So we pop an element and we increment the remaining one. Okay, we increment the remaining point. This is how we are doing. All right, come out of the loop. Okay, check the priority queue again, number of updates, set all the elements to 0, again increment the count variable. That is how it goes. Okay, so the key takeaways from this question were, key takeaways from, wait a minute. Yeah, the first one is the range, as I said, in till that sum pointer. The second is that you need to check for all the indices that if it is occurring to at least twice or not. Okay. at least two times or more. All right. And you need to count the operations now. Ops is less than equal to possible answer or not. If it is, then return true. Okay. Fourth key takeaway is that m plus 1 is not an answer. Okay. So you can check from the range 1 to m. All right. But you can check it for m to 1 and m plus 1. If it comes out to be m plus 1, then you return false either ways. Okay. So, yeah, these are the key takeaways. All right. Uh, and yeah, that's kind of it. The complexity would be somewhere between, you can say, n square for this, not n square, sorry, n log n only, yeah, n log n into log n because you are using a priority queue as well. So it's like log n for the binary search, and this function would have n log n functionality, time complexity. So that comes out to be n log n square, that kind of a time complexity. Space complexity is again O of n. All right. And worst case, it would be log n operations के लिए O of n. So n into log n. That would be the worst case space complexity. All right. Yeah. I hope it's kind of clear. I would have been able to give you some insights into it. It's very important to now that the contest is over, that you guys read the hints for it and then try to build upon your solution. Okay, because this is a very good problem. Okay, this is a proper competitive programming kind of a problem. At every step that we are checking and using priority queues within binary search, this kind of gives you a code forces sort of a question vibe. Okay, so if it is greater than zero, then you push the negative value because you try to set this to zero as soon as possible. That is why you are pushing the negative value. Okay, that is the greatest value would come first and the smallest would come at the end, and you're pushing the operation as well. Okay, so again, try to get some insight. You will take screenshots of my code, so maybe this would be helpful for you. Okay, now I think this finishes the discussion for the contest. Again, I'll just lastly, as we do a ritual, that we'll rate the problems. So the first problem was 1 out of 5. Second problem was 2 out of 5. Third was 4 out of 5. And the fourth question was 5 out of 5. Okay. So these two were difficult today. So as I said earlier in the beginning as well, this contest was more on the difficult side. And I hope you guys would have done well and do not get demotivated by one or two contests. Okay. So yeah, let's meet up in the next discussions probably. Till that time, happy learning. Have a great weekend. Bye bye.